This is going to be Leetcode 173. It's the binary search tree iterator. Binary search tree meaning anything less than a root node or a node will be on the left side, and then anything on the right side would be greater than it. So we're implementing an iterator over a binary search tree. Calling next on it will return the next smallest number in the binary search tree. So this is our example, and I did this question a few days ago. So instead of doing questions that I did the day of, I think it might be helpful to do something that I haven't done so recently. So yeah, and then pretty much the purpose of these videos is to try and explain my thought process on how I come up with these solutions. So we have kind of a structure of our class kind of laid out for us, and a tree node as well that has a value, a left and a right value, and left and right are initialized to none at first. So we have some class. So we're implementing two functions, the next and has next. So next, and we want to get it. So calling next returns the next smallest number from our binary search tree. So if you think about it, here, if we call next with this tree, we should get 3 first, and then has next, we'll say true because it has other nodes next to it. And then if you call next again, so when I write stuff, it's only when we call the next function. Then we call next again, 9, next, like so. Right, and then the first thing I would think about when I see this, and then from here, if you call has next, it will return false. So the first thing I think about is this is in order, right? It's like, it's pretty much just how an in-order traversal looks like, and it's coming back to me now. I'm trying not to remember, but and just really solve it out. But yeah, so pretty much this is an in-order traversal. So my plan is to initialize an array that looks just like this, and then we can't just finish there. Like, I guess if we have this, we can have an index that we could keep track of, and then if the index is not equal to the length of, actually no, that is pretty much how we would do it. So keep track of an index and this array that we'll create when we initialize our iterator class, and then while this index is less than the length of the array that we created, we can, every time we call next, we would move our pointer over to the right, and then we can say, you could return a Boolean value has next if I is less than 0, 1, 2, 3. So this is the length and less than the length of array, right? Because if it's equal to the length of the array, or it would be less than the array minus 1, right? Because if it's here, we return true. And then if we're here, 1, 2, 3, 0, 1, 2, 3, right, index 4, right? And then when we're at index 4, length of the array is, the length of the array is 5, right? And then index is going to be here at 4. If it's less than will return true. So it has next, yeah. But if it's less than the length of the array minus 1, well, it's that, it would return true. But then here, before is not less than, here would be 4, no, so we return false, yeah. Sometimes I get caught up in those types of questions. Yeah, so let's go ahead and implement this. So we have a class, I'm just going to shorten it, BSTI. And then we would initialize something, init self what are we initializing? So we need to take in a root, actually, right? So they have it written out already, but yeah, so we take in that root. Self, root, which would be the root node that we're given. And then, I need another, whatever, let's just use it. So we'll say self.array, and this is going to be our in-order array, is equal to empty first. And then we'll say self.idx is going to be 0 at first. So I'm just going to write our in-order traversal here so that we can create that array that I just erased. So we define in-order self, and then we'll take in that root node, and then so in-order is left, middle, and then right. Right, so we'll take in that array, and then we'll just change it in our function. Right, so if not, root, return, else, array, oh no, not yet. We don't add yet. We'll have to recursively call this function self.inOrder, root.left, that array, and then we add it. Array.append, and then we're adding the value, not the node, right, into our array. And then recurse down onto our right side as well. Right. So that would go, like in this case, we would start at 7. It's our root node. And then, not root, no, else, go to the left. And then we'll be at 3, if not root, no. And then we'll add into our array, 3. And then the left and right value of 3 is none, so we'll go back to our stack, and then we'll add on to this array our 7. And then we will go right, and then we don't add this yet. When we go right, we go left and right first, and then we go to the 9, we add that, and then we add the 15, and then we add the 20. So yeah, that's what we wanted. So now we have this. We'll call our function to create that, or to change our array. Self.inOrder, self.array. So now self.array is this. We have this already. And this is going to be an O of n time when we call this function. It's going to go through each of the elements once, and then also O of n space, because we are storing this array. So if your interviewer says you can't do that, then you have to come up with a different solution. But for now, this is going to help us pretty much make our next and has next calls O of 1. So yeah, let's do define next, and then this is returning the next number, right? So go next, self, and let's see. So next is just returning the number. We already have what we need, so we don't need anything else. Parameters. So next up, self. If idx is less than self. Idx is less than the length of self array. So let's say we're here. Idx is less than the length of the array. Answer equals array at that given index. And then we would have to increment idx plus equals 1. And then we would return the answer, of course. So let's see if that would work. So here, idx is at 0. Answer is going to be this. We're going to store that. We're going to increment I over. Increment I over, and then we're going to return this answer. We're going to return 3, right? So we do that. Boom, done. We call it again. Increment this. Return 7. Done. Increment. Return 9. Done. Increment. Return 15. Done. Increment. Return 20. Done. Try it again. idx is not less than the length of the array. So return, what do we want to return here? -1. Okay, so it says the call is always going to be valid, but we can just choose to, yeah, I guess we just return out like that. That works too. Or we don't even need this actually. But yeah, and then the has next function is, it's pretty much, it's very simple actually. Define as next in self, and then we're always just using that array. So, I erase what I had. So if idx is less than, well, we could just return that in one line actually. Return idx is less than length of self that array -1. Done. You don't need the parentheses. So yeah, so if we return here, idx is 0, 0 is less than 4, so we can return true. If we're at 4, 4 is not less than 5 minus 1, which is 4, so we return false. And in every other case, 2 is less than 4, so we're fine, return true. And this is our iterator class. Next is going to run in its constant time of 1. We're just getting, we have an index already that we're maintaining here, so we can just boom get that. And then increment idx has next. We are just comparing two integers. So that's also constant time. Yeah, so the bulk of the runtime is in the initialization of this class. And that's O of n and O of n space as well. Okay, thanks for watching.